Good evening and welcome to Mrs. Spencer's Math Lab. It's a pleasure to be with you again today. And if you're a first-time listener, I'd like for you to get paper and pencil. This is not a lecture. We do this together. And also I'd like for you to hit your little marks and arrows on the side so that the screen will become larger and you can see the board better. Tutoring has been one of my passions because many times students cannot get it from parents because parents sometimes don't have the patience that tutors may have. Sometimes students leave school not really understanding, so that's where I come in. But my attack for tutoring is from concepts, and from the concepts we go to the processes, and then we work from there and make applications with word problems and the like. So my choices for the different topics that I have used has been because I have tutored students in these various areas. But once school starts, I would like for you to text me to let me know what areas your child is really having problems with at that time. So when the time comes, you can do that. I'm also on YouTube. All of my videos are on YouTube and also on Facebook. When you go on YouTube, please subscribe, and that will help me as well. So today, our subject again is equations, and this time we're going to work on simultaneous equations. Simultaneous, things that occur simultaneously happen at the same time. For example, this afternoon, it was raining and the sun was shining at the same time. There are other things that happen. Whatever's happening at the same time, we say it's simultaneous. We used to play a little game to see if we could rub our stomach and pat our heads. You try that. That's kind of difficult to do, but that would be a simultaneous fun thing to do. So let's get to the equation. We call them simultaneous equations simply because there are two or more equations that are solved at the same time with the same variables, and the variables have the same value. Two or more equations solved at the same time with the same variables, and the variables have the same value. So let's look at it and see. Now, we have already worked with equations that have one variable. And every time we work with an equation with one variable, we have one equation. So today we're going to work with equations that have two variables. So we're going to have two equations. And what is your guess if we had three variables? Yes, if we had three variables, we'd have three equations, and so on. But today we're going to do just equations with two variables. So that means we have to have two equations. All right, just to look at what we do, because we can only solve for one variable at a time. Remember that. So we have to make some adjustments that will help us to have only one variable in our equation. So if you take a look at this that I have here, these are the steps that we will take. Today, I have chosen equations that are already in the same order. That means the x's are on x's and y terms, or the variable terms are on one side and the numerical terms are on the other. So I have already arranged that for you today, so that will not be a problem. So we number the equations, because if we use only one equation, that means we're solving one equation, and it may not work in the other equation. That makes sense. So we have to solve one equation and then put that answer in the other equation and then check it with the so we're back and forth with equations, so that when we put in the variables, the values of the variables, that it will be true for both equations. All right, and then I will show you as we work. Let's take an easy one. Let's take x plus y equals 1. And 2x minus y equals 3. And these are our simultaneous equations. There are two equations. The variables in both equations are x and y. It's in the right form because the variables are on one side and the numerals are on the other. So you didn't have to do that. I did that for you. And you have to eliminate a variable. We have to eliminate a variable and solve for the one that's left. So let's number these equations. I'm going to call the top one 1 and the bottom one 2. So I have numbered the equations so that I be sure that I use both equations as I work. All right, so we looked at these variables. We have x here and 2x. We have y here and negative y. Now, today we're going to only be using addition to eliminate a variable. I can eliminate a variable if the signs of the variables are the opposite. Because we know if I add y and subtract y, I'm back to 0. If I walk up 2 steps and back 2 steps, I'm back at 0. It's the same thing with variables. So looking at this, I can eliminate y. I can eliminate y by adding. So I'm adding. All right, so I have to add each of these in the equation. So x plus 2x is 3x. Because x means 1x plus 2x is 3x. All right, y plus negative y is 0. So that goes, the y's have been eliminated. And then I have to add 1 plus 3 is 4. All right, let's see, did I get those signs right on there? X plus y equals 1 and x minus y. Okay, that's what I looked at the two equations. All right. Okay, the y's can be eliminated. X plus x is 2x. Okay, we're back with the right problem. And we now know that x is being multiplied by 2. The inverse of multiplying by 2 is dividing by 2. And we get x equals 2. So we have now found the value for one of the variables. So now I'm going to equation 1. And I'm going to put this in the place of x. So now I have 2 for x plus y equals 1. And we solve that equation. Solve that equation for me. Solve that equation for me. Okay, we do the inverse of what's being done to the variable. So we're adding 2, so we subtract 2. And, of course, this 0. And we have y equals 1 minus 2. So that's the same as 1 plus negative 2. All right, the sign is going to be negative because the absolute value of the larger number is 2. All right, and so it's 2 minus 1 is 1. So y equals negative 1. All right, so now we've used equation 1 to find y. We added the equations to find x. Let's not stop here. Now we go to equation 2. And we plug in both of these values because we know they work for equation 1. But we have to make sure that they work for equation 2 as well. So I don't have room to go out to the side, so I'm going to come down here, bring this equation down here, and I'm going to have x, which is 2, minus y, which is negative 1, equals 3. All right, let's see if that's correct. 2 minus negative 1 is the same as 2 plus the opposite of negative 1. So that would be 2 plus 1 equals 3. All right, so we have solved these equations, and we know now that x equals 3, x equals 2, and y equals 1. And this is the way we show that. We show it like x comma y. All right, x comma y, the lower alphabet comma the higher one. All right, so how would we express this answer? So x is 2, so our result is 2 comma negative 1. Okay, that seems like a whole lot to do, but it's really not hard. Let's go back over what we did. We have two equations. They're already in the right order. Right order means the x and y, the variables are on one side and the numerals are on the other side. And we want to eliminate a variable because we can solve for only one variable at a time. It's easy to eliminate the y's because they have opposite, they have the same coefficient. Both of them are 1y, 1y. And if they had different ones, and I'm going to put that on you at the end to see if you can do that one, kind too. And we add those two equations. So x plus x is 2x, 1 plus 3 is 4, and x equals 2. All right, then we went to equation 1 and plugged in the value that we had found and solved for the other variable, which is y. And we found that y equals negative 1. And then we go to the second equation and plug in both of them to see if it was also satisfied the other equation. Nothing to it. It's just, to me, it's just a fun thing to do. All right, let's try another. All right, the method for doing it is still up on the side, and you can look at it so that you can do each step. All right, so let's do another. And I'm going to ask you some questions as we go. And the questions are the questions that you have to ask yourself as we work these. So the next equation is 2x plus 3y equals 6. And the other equation is 2x minus 3y equals 6. Okay, so we can number them 1 and 2, and it really doesn't matter which one you call 1 and 2. We just number them so that we know that we are going from one equation to the other. All right, so I'm going to number this 1, and this is 2. All right, now I have to look at the coefficients of the x's and the y's. Here I have 2x and 2x, but if I add that, I'm going to get 4x. That's more. So I can't eliminate the x's by adding. Can I eliminate the y's by adding? Yes, because one is positive 3y and the other is negative 3y. All right, so we're ready to begin our process. All right, add those two equations for me and let me see what you get. This is fun. This is just something to challenge you just a little bit. One day we're going to do 3 equations, 3 simultaneous equations, and that's a little more detailed. All right, I hope you got 2x plus 2x is 4x. And remember, nothing happens to the x's. When you add boys, you get boys. When you add x's, you get x's. When you add dogs, you get dogs. Whatever you're adding, it's the coefficients that we add. All right, positive 3 plus a negative 3y is, they cancel out, and we have equals 6 plus 6, 12. Sure, you can solve this equation. What is the value of x? All right, x is equal to 3. All right, x equals 3. All right, so now I'm going to equation 1. And I'm going to plug in the value for x. So it says 2 times x, which now I know what x is. I can plug it in. 2 times 3 plus 3y equals 6. All right, now solve this equation. Solve that for me. I'm going to wait a few minutes and see what you got. Okay. Okay, 2 times 3 is 6. 6 plus 3y is 6. Okay. Subtract 6 from both sides. And I'm putting in all little steps for you. Okay, and I now know that 3y equals 0. 6 minus 6 is 0. Okay, and I divide both sides by 3. And y equals 0. Now we can divide 0 by a number. But remember, you cannot divide a number by 0. It's undefined. I could not have 3 divided by 0. Always remember that in math. You can divide 0 by a number and get 0. But a number divided by 0 is undefined. Okay, so we have now the value for x and the value for y. So now we've just used equation 1, so now we're going to use equation 2 to plug these 2 values in to see if these values work for this equation as well. And we have 2x, I'm going to write it so you know what I'm doing, minus 3y equals 6. And plug in the values for x and y. 2 times x, which is 3, minus 3 times y, which is 0, equals 6. All right. Solving this, we have 6 minus 0 equals 6. And 6 equals 6. All right? So if we plug it back in either one of these equations, it works. If we had it up here, it would be 2x plus 0 equals 6. And 6 equals 6. So we can check it with each equation. But we must go from one to the other to be certain that what we find as the answer. How do we express that answer? X is 3, 0. Y is 0. So that's the solution for that problem. Questions? Let me have your questions if you have any confusion about the steps. Again, they're in the same order. Remember the equations. so that we can go from one to the other. We add or subtract the equations. We can add, or well, we call it just plain adding, because we know now that subtraction is adding, the opposite. So we really are using addition. So we add when the coefficients are the same and the signs are opposite, because we know if we walk 3 steps and go back 3 steps, we're back at 0, and that's what that gives us. It's like 6 minus 6, 3y minus 3y, whatever. All right, then we plug that value into the equation that we have numbered 1, and then find the other variable. We can find only one variable at a time. That's why we have to eliminate. We can't find x and y at the same time. So the first method of eliminating is by addition, and that's what we're doing today. There are some other methods of elimination, which we will do probably later. Questions? Let me have them if you have questions. Is there any step that's confusing to you? All right, I'm going to put one up, and I'm going to not do anything, and I'm going to just give you a few minutes to see if you can solve this. And I picked easy numbers, as I always do whenever you're introducing something. And I looked at some of these in some of the textbooks, and they have the hardest problems to introduce. So we don't know whether the student's having problems with the problem or the numbers. So today I have tried to choose equations that would be easy for you to work with. All right, let's do x plus 3y equals 11. And the other is x, can't read my own writing. No, I don't want to give you that one yet. That's one of the others. Okay, I'm going to do this one. That's one that you're going to have to do an extra step, and I don't want you to start that yet until I show you what to do. All right, let's do 3x minus 4y. 3x minus 4y equals 11, and negative 3x plus 2y equals 7. All right, remember, we have to decide to eliminate one of the variables. These are simultaneous equations, 2 equations being solved at the same time. The value for the variables is the solution for each one of the equations, and the steps are right here. We want to eliminate a variable and solve for the one that's left. Number your equations, and I'll call the top one 1. We don't have to do that. And 2 is this one. All right, so these are our equations. So I'm going to pause for a minute. Simultaneous equations are fun to do. And let's think of it that way. Let's think of it that way. This is 11. This little dot on my board is a mark on the board. But this says 3x minus 4y is 11. Negative 3x plus 2y is 7. Right? So challenge yourself. And when you finish today, let's rest the rest of the day. But tomorrow, see if you can do some simultaneous equations. And go online. There are many examples that you can go online for various sites and get the same problems that I have chosen for you today and others. All right, so if you have found one of the variables, why not just let me know by telling me with what it is and the value of it. Now remember, you have to plug that into the first equation, the one you numbered number 1, to find the second variable. So let's do that. These concepts used to be taught on the high school level in algebra. But I noticed that some of these concepts are taught in the middle school with students who are not taking algebra. So a lot of the concepts have been moved down, and I'm sure some parents are having a difficult time helping their children, and that's what I'm about, helping you help your child. And again, if you have some area that you would like for me to discuss that your child is having difficulty with, feel free to let me know. And I will make that one of our discussions, one of my nights on Facebook. Again, I'm also on YouTube. All of mine, I think this is the 12th video. So you can go back and look at some of the other videos. Some are on whole numbers, some are on integers, some are on decimals, and some are on equations, some are on fractions. We have not done percents yet, but we shall, and then we're going to relate decimals, percents, and fractions. I just helped a student yesterday who had that to do, and that student is going to grade 6. So he already has had fractions, decimals, and percents, and how they relate to each other. So things are moving faster in school, and I don't know sometimes whether students are mature enough for it at certain ages, but it's being done, and we have to tackle it. Okay, let's get together now. I hope you realize that the x's can be eliminated, because both of them have coefficients of 3, and one is positive and the other is negative. So the x's cancel out. We add negative 4y plus 2y is negative 2y. All right, remember, negative 4 plus 2. The sign is negative because the absolute value of the negative number is 4, and the absolute value of the positive number is 2. So we choose the value of the one with the higher absolute value, and that is, and then we subtract. 4 minus 2 is 2. All right, and we add 11 and 7 is 18. All right, so what did you get for y? What did you get for y? I don't think I copied that right, did I? I didn't copy it right, but we'll go ahead and work this one since we started it. All right, so we divide both sides by negative 2. And we know that then y equals negative 9. Okay. Okay, so we go to the first equation, the one we numbered 1, and we plug in. We have 3x minus 4 times negative 9 equals 11. Okay, this is not the problem. I solved each problem that I gave you before I came on. So this one we're solving together because I didn't quite write it exactly right. So I'm not sure what the answer is for this one yet. All right, so we have 3x. Negative 4 times the negative 9 is a negative what? It's a positive what? 36 equals 11. Okay. So So we subtract 36 from both sides. Okay, and we get 3x equals negative. Now, how do we know it's negative? Because the absolute value of the 36 is 36, and the absolute value of 11 is 11. The one with the larger absolute value is negative. Then we subtract 36 minus 11, and we get 25. This is going to give us a little more problem. 6 minus 1 is 5, 3 minus 1 is 2. All right, this didn't come out an even number today, so it challenges you with a little fraction. So 3 over 3. Okay. And x then equals negative 25 thirds. And I am not going to change that to a mixed number or any other form because it's easier to work with in this same form. All right, so now we go to equation 2. And we plug the value of x in. So we have 3 times 25 thirds plus 2y equals 7. Okay? Did you get that? Solve for y. All right, the 3's cancel out. Remember that? I'm not going to divide. I'm not going to multiply 3 times 25. Cancellation is something that keeps you from having big numbers. Because the bigger the numbers get, the more likely we are to make mistakes. So we have 25 plus 2y equals 7. And we subtract 25 from both sides. Okay. And we end up with 2y, because this canceled out, equals negative what? 18. Okay, so this is a little more challenging. And 2y equals what? And y equals negative 9. Divide both sides by 2. Okay. Okay, you know what? I hope you didn't do what I just did. We already have y. So I needed to plug into what? I needed to solve for x. Okay. So y equals negative 9 and x equals 25 thirds, negative 25 thirds. So we go here and we plug both of them in. That's what I did not do. So when you get to your second equation, you put both variables in, and see if it equals 7. Okay, so it'll be 3 times, I'm not going to write the equation over, 3 times 25 thirds plus 2 times x, which is 2 times y, which is negative 9. That should equal to what? 7. And let's see. So we have 25. And 2 times negative 9 is 18. So 25 plus negative 18 equals 7. And when we add, so that's like 25 minus 18 equals 7, and it is correct. All right, so how do we express the answer to this problem? X is negative 25 thirds. Let's see, did I do negative here? Negative 25 plus, okay. Let's see, have we got a mistake somewhere here? Or am I doing something incorrect? Huh?
Y minus 9.
All right, y is negative 9, and x is negative
25 thirds.
25 thirds.
That's correct.
All right, and here this should be negative 25 plus negative 18, which would be minus 18.
Oh, that's right.
That's not going to give me 7. Okay, so something is a mistake somewhere. Because negative 25 minus 18 is not 7. Positive 25. All right, because this was negative. That's it. Okay, I left off a sign. This is negative 3x. And that's negative 25. All right, so that's plus 25 minus 18 is 7. Okay, that gave us all a little the fractions are a little more difficult to work with, but they can be done as well. All right, I'm going to give you another type just to go a little farther, where you have another step in order to eliminate. Just as I check myself as I go, that's the same thing you have to do. I have students who make it right whether it's right or not because they just assume that it's right. But just like I checked and saw that something was not right, you have to do that as well. Do not just go ahead and write it in as if it is. I've had students solve an equation wrong and say it's right because they didn't check. Check your work every step of the way. Okay, so I'm going to give you something a little bit different. Let's see. If I gave you one like 4x plus 3y equals 15. Let me make sure I'm writing it correctly. And 2x minus 5y equals 1. 4x plus 3y equals 15, and 2x minus 5y equals 1. All right? Well, we have to eliminate a variable. But no variables have the same coefficient. For the x's, we have 4 and 2. For the y's, we have 3 and 5. So we can't just add these equations because we're going to get more of both. And we're trying to eliminate one. All right? So I have a choice. I have 2 and 4. And if I multiply this equation by 4, negative 4, the x's will go out. To get the 5's out, I've got to multiply both equations by something because the least common multiple of 3 and 5 is 15. So I got to multiply one equation by 5 and the other one by 3. So which one do you think I'm going to do? The one that's the least amount of work. And that should be your choice as well. Now, what did I say? I found the least common multiple of the coefficients of my variables. The least common multiple of 2 and 4 is 4. The least common multiple of 3 and 5 is 15. Now, if I try to eliminate y, to make these y's the same, then I have to multiply one equation by 5 to make this 15, and multiply this equation by 3 to make it 15. On the other hand, if I use this one, I can multiply, this equation is okay, because I can make this 4 by multiplying the whole equation by -4. Why do I use -4? Because I want the signs opposite so that I can add. Okay? So I'm going to multiply everything by -4. Okay, and I put it up there because I don't want you to forget that you have to do each one of these. Okay, so I can write the first equation over because I like for them to be one under the other. 4x plus 3y equals 15. Now, when I multiply -4 times 2, times 2, -4 times 2, -2 times 2 is -4x. -2. I don't know why I put those 4's there. Talking sometimes and writing at the same time can make you say one thing and write another. Okay, well, let's go back over that so there's no confusion. I want this to be 4, -4. So the least common multiple, it was 4. So I need to multiply 2 by 2 to get 4. So I need -2 so that when I add, I will eliminate the x's. All right, so this is -2. -2 times -5 is positive 10y, and -2 times 1 is -2. All right, let's check back through there and see that we did that correctly. -2 times 2 is -4. -2 times -5 is positive 10. And -2 times positive 1 is -2. Now we can add these and get an answer. All right, so we have the x's are opposite. So we have 13y equals 13. 15 minus 2 is 13. So what's the value for y? Y equals 1. All right, do I need to go back through there again to show you why I made those decisions? And I will at the end come back to that. All right, so I know now that y equals 1. I'm going to equation 1, and which is my equation here. And I'm going to plug in for y. So I have 4x plus 3 times 1 equals 15. Okay? And 4x plus 3 equals 15. Okay? And we have subtract 3 from both sides and get 4x equals 12. And divide both sides by 4, and we have x equals 3. So we have solved this, we hope, but we got to go to the second equation and see if this makes this equation true as well. All right, and the equation is, and let me make some space here. Okay, 2x, that's 2 times 3, minus 5y, that's minus 5 times 3 equals 1.
So y is 1.
All right. All right, let's make sure we plugged in right. 2x, that's 2 times 3, minus 5 times 1 equals 1. Okay? So we have 6 minus 5 equals 1. And that is correct. All right, so how do we express that answer? All right, so when we express that answer, we say x is 3 and y is 1. And anyone looking at this equation would know that 3 is the value for x and 1 is the value for y. That's interesting little activity. And you've solved 2 equations with 2 variables. One week we're going to do 3 equations with 3 variables. That's really going to be interesting. All right, but these are simultaneous equations because they're 2 equations that are solved at the same time. They have the same variables and the value of those variables are the same. And we really use the techniques that we already have for doing equations, with the exception that we have to eliminate a variable. And once we eliminate one, we can solve for the other. Then once we solve for that one, we can put it in the equation and find the value of the other variable. Now, because we have 2 equations, we must make sure that it works for both of them. So what do? We go to our second equation and plug in both of those values to see if it makes the equation true. So today, again, we've done simultaneous equations, and that's 2 equations. Today, it's 2 equations that have the same variables with the same values for the variables. And they are simultaneous because they all both occur. So I'm going to put one more for the road up here and see if you can do that. We just have a few more minutes and see. I'm not able to see what your remarks are, but I hope you are saying I got it, because it's not difficult. It just looks like it takes up a lot of paper, and it does, but it's not difficult. I'm never going to say that it's difficult, and that's what we do to ourselves. We say that, and it makes it so difficult for us. All right, suppose we had, okay, I'll try this one with it. And somebody's going to solve it. I wish, now when I put problems like this on the board for my classes, the challenge problem, I usually give them something tangible for doing it correctly. All right, 3x minus 4y equals negative 11. 2x plus 3y equals negative 4. And you have to eliminate a variable. And what's so funny about this one is that, again, neither one of them, and the other one of them was okay. We didn't have to multiply both. But this time, you're going to have to multiply both of these equations to make them work. Because the least common multiple of 3 and 2 is 6. And the least common multiple of 3 and 4 is 12. So you decide which one you want to eliminate, the x's or the y's. But remember, you have to, this time, you're going to have to multiply both equations in order to get one of the variables to be eliminated. Now, as I said, 3 and 2. And then least common multiple is 6. So that means I have to multiply this equation by 2 and this equation by 3. Now if I chose this one, 3 and 4, okay, the least common multiple is 12. And I had to multiply 1 by 3 and this one by 4. And as I told you, it's easy to always choose the thing that's easiest for you. And I think multiplying by 2 and 3 is probably easier. But you don't have to. Either one will give you the correct result. All right, I'm just going to pause a minute. And I want to see if somebody can get the answer. When you found one of the variables, put it online and let us know what you did, what you got. I always like doing simultaneous equations. It's a challenge. You got to stay focused, and you got to put to practice all the stuff you know about addition and subtraction and solving equations. Addition and subtraction. Because see, if we add them like they are, both variables would still be in the problem. Did anyone find one of the variables? Did you find X or Y? I think I found Y first. I eliminated the X's. But if you eliminated the X's, then you will find the Y first. Depends on which one you eliminate. All right, I'll be waiting for somebody to put an answer up there. Simultaneous equations. Today we did 2 equations at the same, solve them at the same time, solve them together with the same variables, and the variables have the same value. All right. All right, I hope someone has already put some answers up. I can't see it, but I hope that you have already put it up. And so that you will work on it, I'm not going to give you the solution tonight, but on next week, that's whatever lesson we go into next week, I will start with this problem and see how many of you solved it correctly. 3x minus 4y equals negative 11, and 2x plus 3y equals negative 4. So you've learned, you have a lot of things to play with in here. You have integers, multiplication of the integers, addition of integers, division. So integers are really in this problem. Integers are the positive and negative whole numbers and 0. I think it's about time for us to leave. And as I said, I'm not going to solve this problem because I want you to work on it. And that's where we will begin next week to see how many of you did this problem correctly. Next week, we probably will not be working on simultaneous equations. I have not yet determined what we will work on. I try to go from elementary ideas, and then some things in algebra and pre-algebra, so that I can certainly challenge different levels of students. Next week, I may do percents. I may do percents. We've done decimals, we've done fractions, and I may do percents next week. But if I don't, whichever lesson we do next week, we will start with this problem to be sure that you remember how to do simultaneous equations. I was listening online and I heard a teacher pronounce that another way. And I left out an L. It's simultaneous. simultaneous. Simultaneous equations. All right, so that's it for today. I hope you have enjoyed Mrs. Spencer's Math Lab today, and I will look forward to seeing you again next week.